Among the billions of stars taking shape in our galaxy long ago, the yellow dwarf sun that would come to light our days would not have immediately stood out as anything unique. In the long view, it was just part of a constellation, nothing more. Another pinprick of light, born from a spinning disk of superheated matter like almost everything else. Out of the planets that formed around this disk, one single rocky sphere near the middle of the pack started to develop differently to any other we know about so far in the universe. On Earth, the sun energized oceans and continents. Our planet soaked up its radiation and things started to stir. In time, life would evolve here. And with it, in the life lineage that would become animals, came the egg. How far back does the egg go in Earth's history? Right to the start? Not quite. At first, 4.5 billion years ago, this place was barely a planet at all. It was more like a condensing cloud forming from debris, ice, rock, dust that circled our fledgling star. It was an aggregation of matter, one of many aggregations orbiting our sun. Earth would have looked like a misshapen blob in those earliest millennia, pulled out of shape by the gravity of the objects caught in its grip. But as this sphere grew, its gravitational pull increased and, slowly, it became rockier. There was nothing gentle about those early Earth days. Not a single rotation passed without the bombardment of new rocks and ice and new showerings of space dust. Some chunks of rock were as big as countries are today, some as big as continents, and some, rarely, were even bigger still. Although the explosions caused by their impact were violent and tumultuous, these intemperate collisions, without any thought or forward planning, delivered the precursors for life. The elements, especially metals, that would become the building blocks of proteins and the structural units of cells and their membranes. These gifts from the solar system are in you now. Many comets in this early period delivered ice, which vaporized upon impact. In our paper-thin atmosphere, water molecules grouped together again, coalesced, and for the first time formed beads at the mercy of gravity. Clouds formed. Rains fell. There was something akin to weather. Cauterized through millions of years of bombardment, the Earth's surface became a hellish melting pot, but there was no stopping the maelstrom of chemical interactions now. Elements shuffled against one another to form minerals which would go on to become extra ingredients in life's cauldron. Unstable isotopes of uranium sank deep into the earth, stoking a fire that still rages beneath our feet today. And the potential of carbon, an atom which can unite with other elements in multiple arrangements, was being explored through a trillion or more chanceful, random interactions. Some carbon arrangements held for moments. Others, in the form of the oldest diamonds, were forged 100 kilometers below the Earth's crust at temperatures of up to 1,200 degrees Celsius, and they are still locked in their arrangements as you hear these words.